Alright, another draft physics video presentation. DraftScience here on YouTube. Anyway, so I'll take on a dissident. Might be interesting for some sort of conversation with these people. So this is, there's a whole bunch of these people who are like the Tesla people, I guess you'd say, or something like that. And they're obsessed with waves. Like they have to explain everything with a wave theory. And ironically, like conventional physics is basically got this wave crap all over the place, and that's not good enough for them. I mean, they want them to say the word ether for some reason. And, they want them to believe. And I don't understand it. First, I don't understand this obsession with ether. It is ironic. I just found out from this video that Einstein used the word superfluous. Exactly the same word I used. It doesn't serve any purpose to worry about what the mechanism of transferring the smallest bits of activity through the universe. It just doesn't matter, frankly, whether you believe in ether or don't. It just doesn't add anything to the equations or to the concept of transferring something that happens over here, a little action, and then you have action over here. And you're transferring it, and we know it transfers at a speed, and we know that it transfers in straight lines. So, you want to believe it's waving, it's okay, but it just doesn't make much sense that something waves billions of miles through space and maintains its polarization and all that kind of stuff, and a wave mechanism. I mean, it looks like, it quacks like, it walks like a torpedo. Why would I call it a wave? Just not much point in it. But anyway, so there's just so much. They call the Schrodinger equation. It's just an equation. It doesn't have any waves in it. And they call it a wave equation. And that's not good enough for them. All the places where they didn't have to use the word wave, and they do. And that's not good enough. And I just don't understand the obsession at all. So if somebody can clue me into why whatever, Fatty, what's his name, Ken Wheeler, Fractal Woman, this guy, and numerous others are so obsessed with why do they need to prove the existence of a medium? Are they want to call it like God juice or something, or Gogello? Why do they need their nothing to be something? Why does nothing have to be something? Why? I just don't get it. It never even occurred to me to think of empty space as something. I never, like, I can go all the way back to being a really, really tiny kid, and I knew the difference between nothing and something. I visualized it every night. I actually had a bunch of optical psychotic illusions in my brain. And I could tell the empty space from the something space. The little bits floating around were different than the nothing they were floating around in. I just don't know why. And, this isn't like it's some sort of talking point. This is like sacred to them. And if they don't, treat waves with the same dignity and respect, they get crucified. And it's just so funny because Einstein basically made every kind of concession to wave theory. He was just almost overtly saying it's the most marvelous theory in the history of mankind and will never, never, never let go of its wonderful wonderfulness. And then he went on to point out how it's probably bullshit, but it's, he did every bit of lip service he could do, and it's not good enough. Anyway, I just can't for the life of me understand what the motivation is. Why does that black stuff in the video, why does that have to be something? Why? Why does it have to be made out of the same stuff the white stuff is made out of? Why? Why? Why is it miraculous to imagine that something could travel, jump, from one place to another and fly through the nothing? Why would the nothing get in its way? I just don't get it. Anyway. So we'll play this video. I don't know, there's parts of it are not very relevant, but he does the 2-slit experiment, and that's the part where it'll get super relevant. But so we'll just start here instead and see what he's got to say.
Physics that describes how an atom works. There are only two particles that you need to know about. One is the photon, which is a particle of light. The other is an electron, which can be considered a particle that moves electricity. And finally, we have the electromagnetic field. Now you can see that I have classical.
So the real point would be is to say, okay, he's saying there's only the description of two particles, but it's really just two concepts. There's the stuff moving the speed of light, the forces, and then there's the stuff that gets moved as force interacts with it. Force tells matter what to do, right? And matter tells force where it's going to be. You could argue, or something like that. Okay, so it's the matter's pushing the force around, the force is pushing the matter around, however you want to look at it. The matter is displacing, so the force, and you could think of the force, the photons, the gravity, the magnetism, as an ether, if you wish. But I'm just saying what it is it does move. It does have energy in it already. And all you do is put that energy in a form, okay, that will affect electrons. And that's when we can notice it. But we don't notice it when it doesn't do that. We're doing a hell of a lot of stuff, you know. You would know it, right, when you're sitting here. There's all kinds of shit going on. There's blood flying through you. There's all kinds of crap going on. And you're not aware of any of it. But if I stick a knife through your hand and some of it's comes spurting out, at, you know, with blood pressure and blah, 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 then you're going to notice it. I mean, you know, that's to me, the physics is just screaming that that's the reality, okay? There's a ton of energy everywhere, but it's only when it's in certain forms does it have some sort of, is it going to make one of our little needles move? Ugh.
And Einstein called out specifically in this description. The classical means that I'm not talking about a quantum electromagnetic field. Classical fields are represented by smooth, continuous flows of force.
Whatever that even means. Smooth, continuous flows of force. I mean, obviously frequency means it isn't too continuous or smooth. What does that even mean? But anyway. I mean, they just really did. When they want to try to make everything into a drop of water in a puddle or something, it just doesn't make any sense. Why?
And quantum fields are represented by pixelated, discontinuous fields of force.
Whatever pixelated means, but yeah, the idea is that there's this little Planck reality, that there's a reducible amount of energy. So I guess this must have something to do with infinities or something. Maybe this breaks their idea that it's a Horton Hears a Who universe or something, and that's why they're so hostile, because, you know, they believe in the Hubies. I just don't know what the hell is going on. Why? I mean, you know, the irony is, I mean, I'm saying Einstein's wrong for lots of reasons, and they're saying he's wrong for the very reasons I think he's right. It's just ironic.
And I mention Einstein here because his special theory of relativity removes the medium that electromagnetic waves propagate through.
Well, so that's just an overt pile of crap in the sense that he said it was superfluous. So all he's saying is I don't need to argue an ether. All right? I'm just arguing about how force is, you know, how motion is transferred. Okay? Action at a distance. And he's just basically saying it Newton. I don't posit a mechanism. I just tell you there is, okay, there are facts related to how force is transferred. You know, that's it. But, I mean, he used the word superfluous. He's just saying, look, it's you want to throw it in, but it doesn't add anything to the recipe, okay? It's like taking a bag of air and pouring it in your cake mix. It just doesn't do anything.
This becomes very important to this discussion, so give me a second to elaborate here.
Yeah, I don't think it's very important, but whatever.
Air is a medium that allows waves of sound and enable us to communicate.
Well, whatever. What it enables us to do, who cares? But I mean, it's, again, it's a medium. He says the words. It's a medium, which means these are little bits that are tied to each other. They're forced into connection to each other. So whether you make the medium out of adhesion, that is, the stuff is sticky, then the little atoms stick to each other on purpose, or you make the medium out of forcing a bunch of atoms into a container through gravity or pressure, and forcing them to interact with each other, the fact is they're interacting with each other. It's a medium. And yes, it waves because any action causes action in all directions. So I can't, water's an uncompressible fluid. So it just means I can't make the atoms go closer together. That takes way too much, takes, all the energy of the universe, so to speak. A huge amount of energy to force water to get any closer. You just can't do it. The electrons are way too powerful. And so you poke it, the energy has to go somewhere. The extra space, you're pushing something in, it's displacing an atom. That atom's displacement has to be spread across all the rest of the water. I mean, yeah, and you're saying space is like that. But there's no evidence that anything does all of this going every place thing. There's every evidence that a photon is one tiny discrete bit and it flies all the way through space. That's what the evidence indicates.
If you remove the medium, you have nothing to wave. Like if you removed all the air from your room right now, you would not be able to hear me because the sound waves couldn't propagate through the air medium. So.
Yes, that's right. But I could throw a brick at your stinking head. No problem. Don't need the air medium for that.
Einstein removed the medium that electromagnetic waves propagate through, and he replaced it with...
So again, he didn't remove anything. He just said, I don't really think the concept is useful. So let's just talk about stuff moving the speed of light, and let's talk about stuff it hits. Yeah, but that makes more sense as a conversation.
The speed of the photon particle. And then he made everything else.
So again, such an established thing, the speed of the photon particle. No, it's the speed of all of the forces, all of them, every single one of them. Anything moving close to the speed of light is moving the speed of light, essentially. So, I mean, this is just more rubbish. There's no doubt about the constancy of the speed of light, the speed of force. So you're going to debunk something by trying to create some sort of doubt that this stuff isn't moving this standard speed, that there isn't all of this standard speed moving through the universe. All the forms of the energy are all moving that speed. You're not going to do... I wish you luck, but you're not going to find any experiments that demonstrate it.
Warp and bend around the speed of this photon particle. So now we think about these electromagnetic fields as fields of mathematics. If you ask what is waving, when we talk about waves now, it's waves of math.
Well, they have to use math just because they don't have a mechanism, right? So just as broken as your theory is their theory. In the sense that there's nothing communicating the idea of going somewhere. There's only one kind. It's a push universe, and if they understood that, then they'd understand how, it's a push universe in the context that plus and minus are dramatically different, red and blue, as you have them here, and that's just the fact. They're opposites in a dramatic way, and so they interact with the field dramatically oppositely.
Now, I know that sounds weird, but this is the result of Einstein's thought experiments, which most people don't seem to have a problem accepting.
Well, whatever. I don't know if most people even understand any part of it, that he creates a fourth dimension and all of the rest of that nonsense. So I don't know how much of that anybody recognizes. So this part of it is weird just because he's using Einstein's relativity theory as some sort of argument against quantum mechanics, and there's just no need to mix the two because they're obviously incompatible. They're obviously two kinds of physics. So, there's forcing one to be a debunk of the other just, to me, doesn't make much sense. The truth is the right answer will answer both questions. The right answer will tell you why there's gravity, and it'll tell you why there's charge.
And finally, the forces that we are talking about are just basic attraction and repulsion.
So there is no attraction, there's just repulsion. So there's the push and the absence of push, and that's all that exists in the universe. And your argument that there's some reason to use the word attraction in trying to clarify. So he's making a video to clarify, to make it more clear. And you're not going to make it by using the word attraction. You're just not. Because if you really analyze all the things that look like attraction, it's really just the absence of a repulsion. It's the absence of a push.
Really, it is this simple. You do not need a complex and deep understanding of quantum mechanics in order to figure out why it's wrong.
Well, that's you're claiming that you're going to make this proof in some sort of mechanical, sensible terms, and you didn't do that. Sorry. It's a really bad proof.
And speaking of why should you spend your time to try to understand this?
Well, all this crap, I don't see how it gets you to where you're debunking something, and this is the long way around so far.
Now, if you're already skeptical of quantum mechanics and modern physics, you probably don't need this slide. If you watch popular videos on quantum mechanics, you might hear how it's weird and counterintuitive to understand.
Well, yeah, and I'd say the same thing about your wave theory. So I don't see anything simple about it. It doesn't work. Okay, that's the fact. The fact is it doesn't make any sense. Photon travels through space with the same polarization for billions and billions and billions and billions and billions and billions and billions of miles. And you're telling me it's a wave. And I'm supposed to understand that. And it's a wave doing two things or something. I don't know. Do you believe in the two-wave theory? I mean, it's waving in two fields of ether or something. You can't draw a sensible picture of any of this crap. I mean, it doesn't make any sense to me.
So then why would the best description of how nature works be weird and counterintuitive? This is what I want to help you figure out.
Well, that's the part where you say physics sort of jumped the shark, is that it gave up on physics being about physical things. So obviously it became a little bit of a, oh, there's a probability god, or there's the, magical entanglements and all the rest of the nonsense they get into. And yes, all of that those are extraordinary claims, and they have less than ordinary evidence. So yes, huge indictment on their, all of these claims that haven't been proven with anything called really good evidence.
You might also hear that it's okay that you don't understand it, because even the best physicists like Richard Feynman didn't understand it. This type of quote here is generally associated with something that Richard Feynman said.
Yeah. And so, so he's going to play the clip. And yeah, it's all a joke. But the joke is that it's not about whether you can understand it. It's whether you can believe it. So Feynman's really arguing for a random God. He's saying the universe, you can't set up the same conditions and cause and effect will turn out to the same results. I mean, he's saying something pretty crazy in the sense that he's saying there is no solid reality, that there is all this space that something can happen in, that somehow it wasn't in this location and it wasn't going this speed, that somehow it's in this cloud of a range of possibilities, and that nothing is ever narrowed down. And so I can't create the same conditions because the conditions are never narrow enough. The conditions aren't a defined place in space and time. Both of those things are somehow now broken, and there is no such thing as space or time.
So let's watch the original clip.
There was a time when the newspaper said that only 12 men understood the theory of relativity. I don't believe there ever was such a time. There might have been a time when only one man did, because he's the only guy who caught on before he wrote his paper. But after people read the paper, a lot of people kind of understood the theory of relativity in some way or other. But more than 12. On the other hand, I think I can safely say that nobody understands quantum mechanics.
Right, and understanding means you can't possibly understand, the photon splits in two and decides to go through both slits. And then when it goes through a single slit, well, it splits in two, even though it doesn't go through two different slits. It splits in two anyway. It interferes with itself. I mean, how can anyone rational understand that? That's why should I even have to make these videos? Everybody should be saying, that doesn't make any sense. That's bullshit.
So you can see that this quote in context is that it's part of a joke, but there still is some truth behind this joke. So the reason why quantum mechanics...
Right. The facts behind the joke are that these are extraordinary claims Feynman's making. The random God. All right? It's totally against the whole Einstein statement, that this isn't a random universe. It's a clock ticking. Tick, tick, tick. It's reliable. These are mechanical systems doing mechanical things. And obviously Feynman was rejecting that notion quite overtly and stating it overtly. And why should a rational person just accept a random God? Why should somebody just walk up to me and say, there's a random God? No, I don't have to believe that. I'm not that desperate.
Is weird and counterintuitive is because it is wrong. And when I say wrong, I mean there are mathematical mistakes and logical contradictions or paradoxes that are built into the foundation of this physics.
Well, his mathematics is terrible here. He's going to use an example that just doesn't make... It's just so trivially stupid. It's as an argument against a mathematical formula. I would say it's wrong for lots of other reasons. So again, it's just so funny. I mean, he's saying we're both agreeing that they're wrong, but his replacement isn't right. And the way we're arguing it's wrong is different, which is just, it's surprising.
And the failure to build a quantum computer will help prove this. Yes, they are fake, and the reason is because quantum state superposition is not real. Quantum state super...
Alright, so he's going into a whole nother feature of quantum mechanics where, obviously you don't, the evidence of entanglement is thin at best. All of this is just speculation, and obviously they haven't produced anything, and they won't produce anything. So I agree, it's all bullshit, but to prove it's bullshit, okay, you have to go through a lot more levels of quantum mechanics.
Position is the Achilles heel for quantum computers. If this doesn't work, then quantum computers will fail. So this statement right here is pretty much the punchline on why quantum mechanics is wrong and why quantum computers will never work.
So his argument about what superposition is see, that's the problem with this word, is it doesn't have a nice standard definition, and so everybody's defining it as a different thing. He thinks superposition is adding two states of two waves, and that the fact that the wave multiplies or gets bigger is somehow a superposition, when no, superposition is meant to mean that the thing can be in all the states at once, and that's very different than combining waves. So, I mean, this already fails in the sense that there's no getting to an explicit definition of what a superposition is.
And finally, this will serve as an example of why you can't just believe in science or scientists. You should be able to increase your own understanding enough to where you can question paradoxical or logically contradicted statements, such as wave-particle duality, and complex math can be quite intimidating. But
yeah, but you still have to answer the questions. You have to be able to draw a picture of it. I'm just saying, you're not going to draw me a picture of single-slit interference. It's just not going to happen. You're not going to draw me the picture because you can't. Because it's going to be an irrational picture.
Just realize that math is a way of describing a concept or a set of concepts that you can understand.
No, it's a formalization of the variables that cause effects. So it's basically just saying, here are possible causes, and this is their effects. And you're just putting them on two sides of an equation and just balancing them, and that's it. So if you identify the causes, you'll get the right answer. You don't identify the causes correctly, you'll get the wrong answer, more than likely. Obviously, you can create a whole bunch of fake math and create the right answer, but it's only right for the wrong reasons.
So let's focus on the photon light particle. This is absolutely the big...
All right, so yes, the very way you're saying it, the single photon light particle. So if that's how you're going to narrow the description, then yeah, you're going to be in big trouble. But you're going to be in big trouble anyway trying to do the same thing with a wave. Because neither answer is correct. There's a frequency. Frequency implies that it can't possibly be one thing. one thing has a real hard time having a frequency.
Biggest problem with quantum mechanics. The simple question that you can ask any physicist is, what is the definition of a single photon particle? It sounds easy enough to answer that, but I'm telling you.
The problem is the word photon was invented like everything else. It's all just cobbled together, and so they use the word photon to describe an event, okay, rather than the word photon to describe a cause. So it's an effect. They're describing the effect is photon. We receive photons. We detect them. We have them cause electricity, and needle moves. That's an effect, the photon effect. What's causing the photon is a little more complicated in the sense that there's elements to the event that makes the photon happen. The event of photon, the effect of photon, is its cause is more, it has elements to it. So you could just make the argument that, like their description of the proton, I don't buy any of this crap that's made out of quarks and all that kind of crap, but if you did, you could just understand that, yeah, photon is like a proton. It's made of quarks. It's made of pieces, and the pieces have to show up in the right order, and then you have a photon. So they're sort of straw manning the argument by saying that physics is saying that a photon is a particle, like, that a radio signal, of 10 hertz or something, is 16 miles big particle. So it's a 16-mile long particle. Obviously, that's not what physics is saying.
There is no answer because of this. The standard definition for a photon is...
Right. This isn't really a very good definition, frankly, of a photon. Okay, to say the energy equals a constant times the velocity or the frequency isn't really saying anything, about what is it made of and what does it do. So I'd argue that this is sort of, it's sort of wrong-headed. The idea is, though, is that what the photon is made out of, the constituent bit, is plankable. But the fact is that everything, how it's going to react, is completely dependent on the condition of the thing you're hitting. So again, this is a tipping point argument. And you could hit something, too slow or too out of phase, and you won't gain any energy in the system. And then you just put it in phase, and you do add energy to the system. So it was the same amount of energy you're using, you just applied it wrong. And that's really, why frequency is significant. But clearly, the higher the frequency, that is, the more often something happens, obviously there'll be more of it in a standard piece of time. So he spends this whole middle of this video trying to make an argument about just the fact that we put everything into a standard, like, how much energy it takes to lift a gallon of water 10 feet. We'll figure out how much energy that takes, and then we'll compare everything else to that amount of energy. I mean, these having standards is perfectly sensible. To say it's 1/10 of a horsepower, for example, is perfectly sensible.
Based upon its energy, or E in this equation. And the photon's energy is proportional to its frequency, or F in this equation. And the kicker here is that this equation is a wave equation. It describes the behavior of waves and not a particle.
Well, that's just silly. You could use the same equation to describe bullets. So, how do you make this make any sense, right? If I fired bullets from a gun, I could use the same equation, to just say if I fire 3 bullets per second, then obviously, and then I fire 1 bullet per second, I compare those two, I can understand there's 3 times more energy in the 3 bullets per second than there is in the 1 bullet per second. Well, not 3 times, it's, whatever, 2/3, two, whatever the number is. It's I should have used 4, right? Well, what number do you use? Because you're always doing the dividing thing. Well, anyway, it doesn't really matter. You get my point. My point is that if I fire twice as many bullets in the same amount of time, there's going to be twice as much energy as there is in the place where I only fired half as many bullets. Just as a argument. The bullets carry the energy. The bullets are going to hit the thing. Whatever thing they hit, there's going to be more energy there per second. So this is so solid a concept. I just don't understand why would he even argue with this concept? Because it's just doomed to failure.
So this is where wave-particle duality comes from. We're thinking about particles, but the math is using wave equations.
It doesn't really matter. And again, the particle physics is so distant from actually talking about particles, right? I mean, who could make this argument? I mean, my whole argument against, the standard model is all this wave crap, this de Broglie bullshit of telling me an electron's a wave and all this other horse shit, telling me a Volkswagen's a wave. So why are these people complaining? I mean, conventional physics is got wave way up its butt. Why are they complaining? It's just insane because they're not saying the word ether. That's why. That's it. That's the only reason. All of their whole argument goes away if they'll just start talking about how the ether is doing all this horse shit.
Now let me show you how to illustrate this using a 3 Hertz frequency example. Anyone can draw a visual representation of this wave equation. You can see we have 0 to 1 second represented on the x-axis. Instead of looking at this as a mathematical sinusoidal waveform, we can easily visualize it as waves of water. The x-axis would represent the surface of the water if it was calm and there were no waves. You can see the 3 wave peaks that happen within the 1 second period of time. So water is the medium that has been disturbed, and the effect of that disturbance.
And how do you are you even projecting the disturbance correctly, in the sense that we know the disturbance it's going this way, it's going a direction, and the whole point is the water is not compressible, so it ends up taking the easy road, which is to pop into the atmosphere, and then it finds out that ain't so easy because now gravity is going to equalize. It's going to have an equal opposite reaction. It's going to push the wave back down again, so it's going to keep the energy. It's going to force the compression to keep going this way because the atmosphere is just as incompressible, okay, it turns out, as the water. It just takes it time to react. So that's all you're doing. You're just saying, well, how long will it take for a gravity to figure out, whoops, I just invaded gravitational space, and gravity's just going to do the equal and opposite reaction, push the energy right back into the water again. So that's why it keeps going forward. The energy keeps going in the direction because there is gravity. If I take away gravity, then that wave just goes right off and flies into space, and it's never going to be heard of from again. So it's only because of the way you're illustrating it that there's a wave at all. The fact is the energy is just saying, I'm going, I'm leaving, okay? And if it can't go in any direction, and you're forcing it to go in one direction because there's no other way to go. The force can't go backwards. It has to go either left, right, or forward. And if you take away left, right, and up and down, then it's stuck with forward.
Are these waves. So now we have a frequency of 3 waves in 1 second of time. In other words, 3 Hertz. Now the 3 Hertz frequency needs to be multiplied by this letter H. So
why would you even do the equation this way? You wouldn't multiply H times each one of these nodes. How do you even multiply it times what? H times 1? It's one node. It's not so again, it just, there's just no way to I mean, they get into the comment section, a whole big thing about this, and it's just funny that it's people are having 24 comments because the guy points out this is just a constant used, it's just a standard used to give you a reference. It's just a reference standard. So when it's H is basically representing the constant, what the number would be if it was a basketball going 40 miles an hour, blah, blah, blah. It's just a standard for which you can recognize everything else by. And so in the end, this is just going to be like, the H is just how many electron volts. That's what the answer is going to be. some form, the constant was established based on what one thing does in 1 second. Not everything does in 1 second.
Put an H by each one of these wave fronts. So each one of these H's represents the energy of each one of these waves. To follow on with our water analogy, I put them...
Right, so if I just make these bullets, okay, so instead of waves, they're bullets traveling through space. And we know that each one has energy. And so, yes, you can multiply that this way. You can do it for each bullet. And you'll get the same answer. So I just don't understand. And so you just compare it to what 2 waves would do, or 3 waves, or 4 waves, or 10 waves, or a billion waves. And obviously light frequency is very high. The higher the frequency, the more energy, the more bullets. The more times you say, give me an H, give me an H, give me an H, give me an H. Yeah.
By the wavefront, because when we get hit by waves of water, we can feel the energy of the wave itself. Now, if you're to think of this as a particle of light or photon, you would somehow have to stretch this photon to be 1 second long in order to encapsulate the energy of this wave equation.
No. So nowhere in the argument, again, is to say that it has to be 1 second long is just silly. I mean, again, that's just how many fish, you could just cut the fish into a billion pieces. I can make fractional portions of time. I'm not obligated to do everything in 1 second. I guess you just understand fractions. I don't know. But Fractal Woman apparently thinks this is a valid argument somehow, that somehow you've defeated this equation by pointing out that, well, if I make 1 second worth of light, then I'll have to make a photon the size of the distance from Earth to the moon and back. No, I wouldn't.
So do you really think that photon particles are 1 second long? Because 1 second at the speed of light is 300 million meters, which is basically...
That's why they defined it, okay? We already know that it's 500 nanometers, you could argue, right, for the average piece of light, visible light. So you could just say 500 nanometers. That's how far it travels at the speed of light. It goes 500 nanometers. We don't have to worry about the seconds anymore. We're at the speed of light. That's the standard. That's the constant. That's what's in the frequency. The F has the speed of light in it. Okay, so that's it. So why would I make it? Well, anyway.
From here to the moon. If scientists use this equation to define a single photon, then I hope you can see that they've gone off the deep end. And I hope you can see how you can easily debunk this idea. And there's
no, I can't see any of it. And like I said, go ahead and defeat the bullet analogy. Let's just make them bullets. And let's just say that the frequency is the arrival of the bullets. And a photon would be, say, 3 bullets. Let's say you have to have 3 bullets. If you don't have 3 bullets, you won't be able to detect it. It could say 2, because that would be the minimum. But let's just say there's 3 bullets. So you can't have a photon unless there's 3 bullets. What's wrong with that theory? Why does that fail?
No question that this is an embarrassingly simple mistake. Mainstream science...
No, there's no mistake. It's, just...
generally tells us that Einstein's explanation of the photoelectric effect proves the particle nature of light, or the photon.
And again, the particle nature, the particle part they're talking about is the fact that it's obviously that they don't say an element, but I mean, clearly they're making a quark argument. They're just saying that whatever a photon is, like a proton, it's made of something that carries in packets, okay, in pieces. So again, I don't know why they don't just say what they should say, which is, yeah, a photon is made of quanta, okay, with a separation of distance between them moving the speed of light with a period, a frequency. And that's it. I don't know why they didn't make that clearer. But clearly that's what they're arguing. They're not saying it, but that's clearly what they're arguing. They're not saying that every photon is itself, that the red and blue light are the same thing. They obviously aren't saying that, right? So they're not saying it's a Planck you know, each one, they're clearly saying there's a constituent that's plankable. Yeah, should be back and such.
This is not a correct statement, and I go into much greater detail in this video called The Quantum Flaw. And around the 3146 time frame in that video, I specifically start talking about the photoelectric effect. Here is a real quick summary. We just learned about the problem with this photon energy equation, in that it is a 1-second wave equation.
So again, it's not a 1-second wave equation or whatever he's saying it is. It's just counting the fact that blue light has a higher frequency. That means more little bits of energy in the same unit of time. So whatever the unit of time is, blue has almost twice as much energy stuff as red light. So whatever you call the stuff that is the energy, there's twice as much of it when the frequency is higher. Right? What's so complicated here? I mean, this is, you're not debunking quantum mechanics with this crap.
Certain frequencies of light are shined onto metal, then electrons are ejected from that metal. That's the photoelectric effect. The problem is that the photoelectric effect happens right away without delay.
Yeah, whatever that means. Okay, this is absolutely who can, what you can say anything happens right away without delay. I mean, any process in the universe. The whole reason why there is time in the first place is because light is moving slower than instantaneously. So I mean, things happen faster than the speed of light. I don't think physics is arguing that something's happening faster than the speed of light. So that anything can possibly be moving faster than the speed of light. So anything could possibly happen faster than the speed of light. So again, it just, where do you get that from? And certainly it isn't integral to quantum mechanics, the existence of the faster than speed of light event. So, but any physicist who's going to tell you how long it takes a photon to cause a reaction in an electron, and they have somehow measured that time, well, that would be fallacious.
And you know, in order for the photon energy to be created, it takes 1 second worth of time because...
Oh, obviously it doesn't take 1 second for a photon to land on a surface and do its photon thing. So that would be absolutely silly to say something that happens in, again, 500 nanometers of space at the speed of light, right? So even if you expand that to say 3 nodes have to land, you're talking about 1500 nanometers of distance at the speed of light. Obviously that's not going to take a second to happen. You know, not even close. It's in gigahertz, all right? I mean, the photons are somewhere in the whatever's after trillahertz or something. I mean, it's an insanely fast frequency.
Because it's based upon this frequency term. That's a huge contradiction. This is Albert
That's just a silly complaint.
Einstein's 1905 photoelectric paper.
So this is very good. I mean, it does have links to these papers, and this is a pretty readable form, so I really appreciated that. Just because, you know, you get stuff on the internet, and sometimes you settle for something that ain't too good. But this is quite readable. So it's good to get the actual, what did Einstein say?
In this third paragraph, this is where he starts to talk about wave-particle duality. He says the wave theory of light has proved itself splendidly and will probably never be replaced by another theory.
So he did take a couple of words out, which isn't too good. You know, which operates with continuous spatial functions, has proved itself splendidly in describing purely optical phenomenon. So he's just making the argument almost for the two-slit experiment, which is ironically funny, because obviously it hasn't done that, and it only did that by propaganda alone. Okay, I mean, the math was wrong 200 years ago. It didn't work as a theory. And again, they never even dealt with the single slit, which is the one that's much harder to explain, where it just completely fails. The wave comparison completely fails.
But that wave theory may lead to contradictions when applied to the phenomena of production and transformation of light. This is where the particle nature, or photon of light, comes into play. So then the simple question would be, if light is produced in discrete chunks, then when or how does it turn into a medium for waves to propagate through?
Right, so those are contradictions. So yes, wave-particle duality was nonsense, is nonsense, and the clear truth is one of these two ideas has to win in the end. And so Einstein's arguing there's pretty good evidence for this fact that it's made out of elements that are indestructible, that are the same constant, and that you're just adding or subtracting these packets, this little packet of energy, a little piece. So it's made of pieces. The pieces are fundamental, elemental, and this idea of it being a wave. Well, it has to be a wave again. If you're going to make the medium, I guess the point would be is you're going to have to make the medium out of the pieces.
I've not been able to find an answer to that, and I'm not sure it exists. So you can see the duality this sets up. In other words, light acting like a wave through a medium versus a particle projectile of light, which are not compatible with each other.
I know, but it doesn't change the experimental result. So again, this argument that you've debunked something, when you have to do that, you're going to have to explain how either the particle theory is wrong or the wave theory is right, and you're not doing either one of those things very effectively. Clearly, you can't deny the experimental results that led to the conclusion that it's clumpy. And so until you debunk the I don't know if the black body is great evidence. And the fact that we use clump detectors is also not good evidence. But I would argue that the facts of how light travels through the universe sort of just is good evidence. The existence of laser beams and the existence of the single slit experiment are pretty good evidence that your wave theory fails.
And then a few months later, in 1905, Einstein released this paper, which is now considered special relativity. In this paper, he talks about the light medium that is required for wave theory, and then he takes it away with this theory. He says the introduction of a light ether, or that is what they call the light medium, will prove unnecessary.
So he said superfluous. So I don't know why he didn't use the word that got translated into with superfluous. Unnecessary is a little bit different than the word superfluous, but frankly, just making it clear that it doesn't add anything. The ether is not necessary. You don't need an ether to explain the dynamic at all.
So in one paper, he says the wave theory of light will probably never be replaced by another theory. And then a few months later, he's changing the wave theory of light by removing the medium for which light propagates. And he replaces it with his own theory based upon the speed of the photon particle through empty space. And then...
Well, clearly people could understand the wave as being very different than having an ether. So they can understand a wave, as these stupid drawings even, as actually something moving through space, doing something. A something is waving its way to some place. So, they don't need to believe in an ether to believe in a wave. So that's where I think you're making your literal semantics mistake, is in assuming that because people said the word wave, they meant ether wave, when that's not necessarily the only way a wave can be constructed in a field, for example.
And that leaves the wave theory of light with a medium of mathematics. We're now waving mathematical fields.
Yeah, right. Just as most people won't say that dominoes wave. Okay, they can say, yeah, they can look like they're waving. It can appear like there's a wave of dominoes, but they know that the dominoes themselves aren't waving.
What the heck is he trying to do here? But that's wave-particle duality. It's confusing. Okay, so the last thing I want to mention is the 1923 Compton scattering experiment. And it definitely is a very compelling experiment for the idea of a photon particle of light. I don't have anything further to say about Compton scattering because I have not spent time with this experiment yet. But
yeah, whatever. So not a great thing to cite then. For your argument, that you left. Oh well, one of the things they claim is evidence. I'll just get around to that someday. Yeah, you sort of have to deal with that. If you're going to say the guy's innocent, then you're going to have to deal with the gun with his fingerprints on it.
An experiment that anyone can do is the double slit experiment, and this is the absolute best experimental evidence against the existence of photons.
Alright, so again, I don't know why he's saying against the existence of photons when that's what we call the energy that lands on a surface, so you can't say there's no photons. It's just kind of silly, frankly. So you have to argue what a photon is. So you have to go back to making an argument about some sort of wave theory. Now, obviously, I have pointed out and demonstrated clearly with that overwhelming, just the argument is so simple and so complete. We're done. The two-slit experiment it's over. It's done. It is not a wave theory. The waves are in the wrong place, and there's way too many of them. It just doesn't make any sense at all. So you can't coherently draw the real thing. So draw it. Okay, I defy you to draw your example. Show how the wave goes into the single slit and the wave comes out of the single slit, and show me where your waves are, and show me how it isn't entirely the surfaces that are causing the phenomenon. It has nothing to do with any kind of wave.
So here's the basic setup for this experiment. We have a red laser pointer and a diffraction slide. The red laser pointer is a 650 nanometer wavelength. The diffraction...
So this was kind of funny because he's using, this is a real diffraction gradient. So you got these little tiny lines over here that are basically creating a gradient. But they're tiny obstructions. So it's less than probably, it's probably somewhere close to the wavelength of light, in terms of these little tiny, you can't even see it, so small. So it's a little tiny single impediment, just this little tiniest, thinnest possible. So there's only two ways you could screw up the double slit experiment. You either make the impediment infinitesimally small, or you make the slits infinitesimally small. And that ruins it just because it takes away the whole meaning of the experiment, in the sense that your two sources now are so close together that it doesn't make much mathematical difference. When it's less than a wavelength of light, or one or two wavelengths of light, the distance is so small that the two sources are essentially going to the same locations. And so all you do is make your spots a little tiny bit bigger on the screen, but you won't change the pattern any, because the difference between the two sources is so minimal that there's no possibility of different vectors. The vectors all have to be essentially the same.
Slide was purchased from Amazon and is made by 3B Scientific. Here's a close-up of the diffraction slide.
So you can see this, it's a very tiny little impediment. And again, they could have done it the opposite way. They could have made the impediment big. I should use my little arrow since I have it. They could have made, little tiny thin impediment. And so they could have done the inverse. They could have made the impediment big and then made the slits little tiny slits. And either one of both of those will turn it back into essentially a single slit experiment. So if you want to turn it back into a single slit experiment, that's how you do it. But if you want to see the double slit pattern, you make the impediment much bigger, and then you make the slits big, and then you'll get lots and lots of interesting pattern. You'll get the real double slit pattern. And you won't be able to explain it with two waves, that's for sure. No possibility of drawing a picture with two waves that mathematically will work.
So now we can see the wave interference pattern that is created when the coherent light source, or the laser, is shot through this diffraction slide or through the double slit. You have the highest intensity.
So we know that this isn't the standard pattern. Okay, the little dots, yes. Okay, now the fact that he's already got some problem because they're not even consistent, which is quite strange. But anyway, because he used such a thin impediment, it essentially meant that the envelope is as big as the pattern. So the envelope pattern is huge because of the tiny impediment. So the shortest distance decides the envelope. The longest distance decides how big the little balls of light are going to be, how many they're going to be. So, if you take away the distance in the middle, then you take away the envelope pattern. Essentially, doesn't become relevant. So that's why it's just a continuous pattern. It's because the envelope is so wide, you can't see it.
Light near the middle, and then you can see the bands of destructive interference where there is no light, So these waves interfered with each other and...
So you can see that these blobs are kind of big. So that's also the second symptom. You know, they're wider than they are tall. And so that's the second symptom of having a very tiny slit, is you create two locations that are very close to each other, so they're projecting a little tiny distance from each other on the surface, so it looks like it's one ball, but it's really the two different sources are so close to each other you can't see the difference. But it does make them a little longer, a little wider than they are tall.
Canceled each other out. And then bands of constructive interference where the light waves add to themselves.
So you didn't prove any of this, so I don't know, you say this, you debunked something. This debunks nothing. There's absolutely no evidence you're showing me of anything interfering, anything doing any of this stuff, right? And again, I could just make this, I can make my scatter argument, and it completely explains the experiment. So you're debunking, I can debunk your debunk. Pretty simply by pointing out that I can explain this pattern without any waves. And do it with mathematics that's precise and always gets the right answer versus your mathematics that won't work.
So light being a wave through a medium, which causes an interference pattern, explains this experiment logically.
No, it doesn't. So it fails completely in the single slit, and in the double slit you had to manipulate it to create this, you know, consistent pattern, because if I do it the right way, you'll find out that, oh yeah, there's two patterns. There's bright, and then it gets, a bunch of them get dark, and then they get dark, and I can show that, but whatever. So, you know, sorry, no sale.
It only gets weird when you add in Einstein's confusion around photon particles.
So I'm just saying it only gets weird, he's saying. Well, of course it already got weird, right? You're saying that the photon goes through both slits. How does it do that? How does it interfere? What's the mechanism? You're not going to draw any pictures of anything. You're not going to give me any physics here at all. You're just saying that there's somehow magically the photon is going every place, and every photon is one photon, and they're all united, and they're all unitotons, you know, from the wave of force. I don't know. There's nothing here.
And the illogical concept of wave-particle duality for light. So let's go.
Yes, that's illogical, but you didn't demonstrate anything. So then he takes a clip from a Dr. Quantum video, which is not a good idea.
Go ahead and play along with the idea of the photon particle applied to this experiment. There are plenty of videos that already go into detail.
Right, and this is just another nonsense. So again, you can't even figure out yourself that if you were to do this experiment with, say, two slits and styrofoam balls or something, or Nerf balls or something, that a ton of them wouldn't just hit part of the surface a little bit and diffract and spread out all over the place. I mean, there's absolutely no reason for any logical person to sit there and say, well, of course, one of them could hit just the edge of the slit and it'd be deflected a little bit over here, and then one would be deflected over here, and it'd be deflected all over the place. So again, there's this is, you're saying you're making a logical proof, and you're saying something that doesn't make any sense to your proof, because obviously, yeah, I could do this physical experiment. And then if I was more precise and I said, well, what if I threw the Nerf balls at a frequency, so they were all the same distance from each other when they got to the slit? Well, I could possibly have one that deflects off one surface and has to travel a longer distance, and now when they arrive, the one from one surface will hit, and then the one from the other surface will show up and hit, and then, you know, and recreate a frequency. That explanation works just fine.
About the double slit experiment, but this Dr. Quantum animation seems to be a very popular one. And you can see right here, if you are shooting...
It's only popular because it's full of woo.
The idea of photon particles through the double slit, you would end up with two dots or two bands, as shown here.
So again, this is the character of your proof when you're saying that that's the way you did the experiment, that that's how it came out. When no, you can't logically defend that that's the way the experiment would come out. That I could do it with tennis balls. I can do it with real things that we all have real world experience with, and that I would have a certain amount of them would end up hitting the edge. And that's exactly what happens in this pattern, right? Most of the light is right there, dead in the middle, right? So this is proving the point. Most of the light is right here. So yes, most of the tennis balls won't hit the edge. But a percentage, 6%, some small percentage, 6 out of 100, will hit the edge, and they will end up getting to the other surface, and in some wrong location. Not in the center anymore. So I mean, you're proving my point, and you're proving that these arguments are really lame. That the wave theory has no real solid defense.
But when you do the experiment in real life, you don't see the two bands of these photon projectile particles. So then,
and again, why would we think the photon isn't? It's a photon is supposed to be something smaller. Maybe you don't think so, but it's much smaller than an electron, for example. Photon's tiny. The little bits, the quanta, is small. Now, yes, the photon travels through space in kind of a big package, but we all know it's not that big, right? You would argue, would you concede that the polarization of light is 1,000 atoms across? So how does something 1,000 atoms across interact with an electron? I mean, obviously that can't possibly be happening. And so how's it work even for your own theory? How do you explain why the wave is a certain polarization, a certain thickness to the wave, and it just travels through that thickness through all of space? It'll travel billions of miles with the same polarization. Why? How? Draw me a picture.
How do you explain photons making this interference pattern? It is because the photons are in a quantum state superposition. And while in that state...
I don't know why he's doing this, because he almost sounds like he's arguing for this position when he's arguing against it. So he's saying that their claim is that there's a superposition state. Well, that state isn't created until it goes through the slits.
A single photon can pass through both slits at the same exact time and interfere with itself. This allows us to see the photon particles in an interference pattern like this, because it is in a quantum state superposition at this time. So if the photon's quantum state superposition were to decohere right now, then it would go back to the two blobs that we saw.
So it's not enough for him. Like I said, that the traditional physics will draw it as waves. They'll basically draw the superposition as a wavefront, demonstrating that it could be in any one of these positions, and it could be in any one of these positions, and that the superimposed states are interfering with each other. There's two superimposed states, and those two superimposed states are interfering with each other. So they already are drawing it like a wave, and he's still complaining. It's just so funny. I mean, it's so ironic.
On the Dr. Quantum picture. As you can see, this is some of the quantum weirdness that people talk about. Sure, it's weird, but it's because it's wrong, not because this is how nature works.
And the part that's wrong about it is the whole wave part of it. The whole superposition, the whole idea that the photon is not a discrete object, that somehow it's in all of these places, that somehow your photon traveling through space is going to all of the locations in some big giant wave, but all of the energy just lands in one place. And as soon as it lands, all the rest of the photons die. All the other places it was going, somehow all that energy disappears. Now,
so from a particle perspective, you're looking at a fully cohered quantum state superposition of photons. What I'm going to do now is add more noise to this environment to try to decohere this quantum state superposition of photons.
So this is more gimmicks. I mean, just antics. No one would argue that you decohere a photon with a hairdryer.
Now, why would I do this? This is why quantum computing is not working. Is based upon noise in the environment.
So now if you did that with humidity, instead of dry heat, you used wet heat, you could see a bunch of weirdness happen. You could affect the pattern. So, I mean, your analogy doesn't even work. Because if you did it right, you could show that, yes, you can disturb this pattern by disturbing some elements that's interacting with the photon. And clearly the photon is being transmitted through a medium, the atmosphere. There's little clear pieces of stuff that are transmitting the photon as it travels.
Quantum computers are not working because they are having trouble maintaining quantum state superposition. And their reasoning is because there is external noise in the environment that is decohering the superposition that they're trying to maintain inside these computers.
I mean, obviously you can never find a place where it's quiet enough. That's right. So, I mean, the whole theory of superposition and decoherence, or whatever they call it, deconstruction of the wave function or whatever they call that. Anyway, yeah, that's, it's nonsense in the sense that Schrodinger cat is already being observed by the universe. You don't need a camera, okay, to do an observation. So all you need is a piece of energy to go into the box and hit the cat. And now the cat's been outed as something. Now you didn't have to see that reflection, but as long as the reflection took place, you already made the cat in a condition. It already had to say, I can't pretend to be both things anymore.
So why am I able to maintain this quantum state superposition?
Boy, that's really annoying. So, just as a production value, let me just point out that, maybe you should mute the volume when you're going to play the game. Shoot your little hairdryer at the screen.
Of photons. So someone that understands the story of quantum physics would probably think I'm an idiot for using a heat gun, because in order to...
it's really just, it's antics. I mean, it's not really very useful, because we already know that photons are traveling through the medium of the atmosphere. The argument is if you could throw something more substantial in the way of the photons, like a bunch of electrons or something, well, then you'd scatter the fuck out of them.
Collapse the quantum state superposition, I need to measure the photons, not try to heat them up. So if you try to measure which slit the photon passed through, then that will collapse the photon's quantum state superposition.
Well, again, the whole measurement argument is moot, in my opinion. First off, measurements are already happening. Gravity's measuring everything all the time. There's no hidden places you can go where you're not being measured. Everything's being measured every gazillionth of a second. Everything's being measured. So unless your whole experiment can take place in a gazillionth of a second, a double gazillionth of a second, whatever, some preposterously short amount of time, then there's no superposition. You could never be in one for very long, because yes, some part of the universe is interacting with you all the time.
It makes sense because somehow photon particles of light know when they're being measured. Yeah, sure. Right.
Okay, so that's not really their argument, so that's straw manning. So again, it just makes your debunk pretty low quality when you have to resort to straw manning the other guy's arguments. So blah blah blah.
Is confusing because it's wrong. I want to mention these variations of the double slit experiment because they seem to be very popular. First of all, the which way did the photon go experiment was a thought experiment. Try to find a single photon detector that can detect which side a single photon went through.
Or an electron detector, for that matter, right. So I've already made that point over and over again. That's always been a big lie that they ever did any of these experiments. No physicist would be stupid enough to even to try. So that's all nonsense.
Again, try to find the definition of what a single photon is. None of this exists.
Well, it is poor. And I'm amazed that people are accepting such a poor description. Nobody's being obligated to draw a picture. Well, I've drawn the picture.
You might see some of these experiments using polarizer material to mark photons as they go through each slit.
Right, so that's just so bogus. So, polarization isn't spin, isn't this, isn't that. So they're just saying that any quantum property will do. And clearly that's really bad logic. And polarizing film doesn't equally affect, it affects the more you tilt the angle, it's less, and it becomes more and more destructive, so it's not equal, and that's why they get these little slight differential in the numbers, is because they don't even understand how polarization works.
But this is physically interfering with the light waves. It has nothing to do with photons. As light passes through the material, it can slow down or be absorbed, which is physical interference, not a measurement.
Well, frankly, it is a measurement, but it is, in fact, changing the phase of the photons, and changing the phase changes the frequency. I mean, it breaks the frequency is the clear answer.
And then the quantum eraser variations that I've seen rely on quantum entanglement. Quantum entanglement requires quantum superposition to be a real thing. So we're just going further off the deep end with these experimental variations of the double slit experiment.
And they're still relying on phase and polarization, because all of those experiments are basically right and left hand glove experiments. You're just saying that yes, you can cause a crystal to create a photon in that is completely opposite. So where one photon, the bullet's here, in the other photon, the bullet's here, and the empty space is there, and then the bullet. So it's dot dash dot and dash dot dash. Okay, and that's all you're doing. You're creating two photons out of phase.
And for the final item in this section, I want to show you where the quantum mechanics user manual is so you can read more about this principle of quantum state superposition. Paul Dirac was one of the original founders of quantum mechanics. This is the third edition from 1948. His book starts.
Yeah, it's really terrible. So yeah, I'm going to try to read the whole thing because this is, I don't know why physics decided to go with all this loop-de-doo nonsense. Dirac it's all mush. It's all religious mush.
With the principle of quantum superposition, because this is the concept that makes quantum mechanics what it is. It's also the same concept that quantum computers are completely dependent upon. I want to pick out a few statements from this section that confirm my quantum mechanics description of the double slit experiment, just in case you thought I'd gone off the deep end.
They went off the deep end, but you didn't go off anything. You just fell in the mud. I mean, I don't know why you're sticking to this old archaic notions. Why? You're religious or something? What is the thing? What is this? Why are you so? Why do you think the universe is made out of some sort of god jello? Why?
I want to highlight here that he says a fraction of a photon is never observed. Here he mentions that...
Right, so that's because we don't have any instrument to measure it. So that's the joke, right? I would argue that a fraction of a photon is observed all the time. Here, look. Fractions of photons are doing this, okay? That's what the fractions of the photons are doing, is all the other forces are pieces of a photon, essentially. Photons without their standard frequency. So if I break light into little bits, it's still a force. And it will cause things to move. Fact. It's still energy. It's just not going to create a specific response that is a bit of electricity. It'll still create heat, and it'll still create movement.
The principle of superposition of states, or quantum state superposition, is one of the most fundamental principles of quantum mechanics. Here is the section on photons interfering. We must now describe the photon as going partly into each of the two components into which the incident beam is split. Each photon then interferes only with itself. I told you, it's crazy. So this paragraph kind of sums it.
And you have the same problem. You have a single wave going into the single slit. Draw me the picture of where the waves are. Your interfering waves. You're saying the same thing, so I don't understand why you're arguing with this stupid interference argument, because you're saying the same thing. You're saying a single photon goes in, and somehow it turns into two waves that interfere with each other. How are you saying something different?
That the superposition principle cannot be explained in terms of familiar physical concepts. So this is an entirely new idea that you've got to get accustomed to.
So that's his argument, Dirac's back then. And so this is just jumping the evidence. They obviously didn't have enough evidence to draw conclusions about what possible theory could ever explain something. So it's not like they had thought of every possibility. They just said, oh, we're smart and we haven't come up with it, so it's time to jump to the desperate conclusion. And that's all that took place here. They just got way too ahead of themselves, way too full of themselves, that I can't think of any imaginable way it could ever be explained by anything rational, so I'm going to go with the irrational explanation. I mean, there are magic tricks like that, right? I mean, some magician performs some trick and you're like, how the fuck did he do that? Right? But there's always going to be an explanation. There really is going to be one. There's going to be some mechanical explanation. But yeah, until you know the trick, it can seem like, oh, no one's ever going to figure that out. Because it's not possible. Yeah, it's possible.
And one that you need to build up an exact mathematical theory, but forget about any detailed classical picture, or I could just say real world picture. You can read this entire section and come up with your own opinion, but what this tells me is forget everything you know, believe these new ideas that are based on math theory. Quantum mechanics.
It's not even based on math theory. Like I said, if they had any respect for math, they would have figured out that 200 years ago, the Young experiment failed mathematically. 2 waves won't explain the double slit pattern. It just fails. The math fails. Fails. That's why they had to keep talking about infinitesimally small slits and they kept making the slits smaller and smaller because that's the only way the math didn't fail. That's the joke of it.
Is a belief system that's based on math. And quantum computers are based on quantum mechanics. Okay, so that is the end of the first part of this video. Here you can see what we're going to talk about in part 2. And one of the most important points of the next video will be around this, the Born rule. It's this man's idea that allows the concept of quantum state superposition to even exist. So both quantum mechanics and quantum computers rely on Max Born's belief in how the world works.
All right. But obviously you just pointed out that Dirac had a huge influence and the rest of them jumped on the bandwagon of bullshit. But yeah, I would argue their mistake was believing any of this wave crap at all. Making any concessions to wave theory was the real mistake. And that's the irony here, is that you think the particle notion was the mistake. No, particles explain it all. Nice straight lines, nice rigid rules. Works great. You don't need any of these bent lines, this wavy nonsense. So anyway, I guess that'll have to do. So yeah, Fractal Woman commented, "This is excellent. I look forward to part 2." No, it really wasn't excellent. It was rubbish. And then there was like 28 comments, 24 comments trying to make the point that you can't deconstruct an equation by trying to destroy the constant that the equation is made out of. It just doesn't make any sense. Everything's just being measured in how does it compare? How many this amount of chalk I could call it something, you know, a chalk-it. Okay, a chalk-it. So this is a chalk-it. And I could say, you know, on a scale, I weigh 768,000 chalk-its. What's wrong with that? There's nothing wrong with doing that. So anyway, and just measure everything based on a chalk-it. Yeah. And somehow he's saying that because I did that, a photon can't be a fraction of a chalk-it, and something else can't be many, many chalk-its. Of course, everything can. So anyway, this is a really bad argument. So that'll have to do, I suppose. Don't really find these numbers terribly believable. 357 views, 31 likes, no dislikes. That's sort of surprising. But anyway, a lot of chicanery going on in terms of view numbers and such. But anyway, till the next time and such. So we'll see if we can provoke some sort of video exchange, but I doubt that'll be possible, but we'll see. But I mean, his videos are critiquable, so I will critique them. You know, he has another one where he's claiming to have proven something. It's just, there's nothing here, okay? There's no proof here. It's just a lousy debunk. And I would direct you to my better debunk. I can actually put them on the screen now, so it'll be on the screen over there. Where I explain the 2-slit experiment. No waves necessary. Anyway, till the next time and such, so forth and whatnot. Yeah, that's enough.